Ha 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 ha! You don't know what you've got yourself into yet. But now you're getting ready to know. Because we're getting ready to start talking about the pieces and parts of the HPLC instrument and how it works and how it does its job as beautiful or as ugly as it can. So, you already know the price tag, $75,000. And you also need to know, before we go any further, we need to make it clear, a mutual understanding between the two of us, that this is a very high maintenance piece of equipment. And you know those people that are high maintenance, right? Oh no, please. All they do is gripe and moan and complain, or they always have to have the best. This instrument's the same way. It gripes and it moans and it complains, depending on the day that it's having, and it always has to have the best. So whenever we order things for it, we just can't settle with the cheapest that's out there. It really has to have everything high dollar, even down to the liquids that we put into the machine. So, it's just like owning a Range Rover. You own a Range Rover, it's blingy, it's flashy, people think you have a lot of money. And then when you pull up to the gas pump, what has to happen? You have to have premium gas in it because it requires the most sophisticated or the most expensive liquid that you can put into it. Well, HPLC is the same way. It's kind of like a Range Rover of the laboratory. So what we want to talk about first is this mobile phase holder. Now, let's go back and talk about this thing called mobile phase. Alright, so if we take a look at mobile phase and we go back and remember the purpose of the mobile phase, well, we've got a column, and this column is filled with what we called stationary phase stuff, right? And we have put a sample into the column. It's a mixture. Different components are in there. And I want to begin separating this mixture into its individual pieces. The purpose of the mobile phase, if you go back and remember that kind of first module of videos about the theory, the purpose of the mobile phase is to take liquid and begin to pour that liquid through, mix it with the sample, and have it go through the column and out the other end. And these mobile phases will come to us in different forms. The mobile phases that we will see particularly, we've kind of already listed them at one point. There's 4 of them. One of them was methanol, which is CH3OH. That's the formula for methanol. The other one's water. That formula you should hopefully know. That's H2O. Number 3 is called acetonitrile. 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 That's CH3C triple bond N. And number 4 is just a run-of-the-mill buffer solution. And the buffers really just control the pH values. So if you're working with something biological, or if you're working with a compound that maybe has an acidic proton or hydrogen that it can donate to a solution, sometimes we don't want proton movement to cause us a problem. So acids and bases are very commonly controlled by buffers, a solution that we use to control the pH of the environment that these things are in. Your body is a walking bag of pH buffer. Your blood has to be a certain buffer, or if it's not at a pH level, then you can die if it's fractions off from the pH of what it should be. So very often, sometimes, depending on what we're running, we've got to put in a buffer into the machine. So up at the top, of these instruments, you will always see a mobile phase tray. And this mobile phase tray, the purpose of it is just to give you an area. It's just a plastic box. There's nothing in it. It's just an area for you to put the jugs of mobile phase into. So that way they're just not out on the lab bench, and they're kind of clustered together, and you don't turn them over, and they're up on top out of reach, because we don't want them contaminated. We don't want people to be messing with them, and we kind of put them up on top so that way they're out of the way. Each one of these jugs will hold a mobile phase. So in one of these jugs, I'll have methanol. In one of the jugs, I'll have water. In one of the jugs, I will have maybe acetonitrile. And then maybe in the fourth jug, I will have a buffer solution. But that's the purpose of the jugs that you see sitting on top of the HPLC instrument. These are the mobile phases that will be used. These liquids will be pulled into the machine, and the mobile phases will push your sample through the machine from the entry of the tunnel to the exit of the tunnel. All right? So that's the purpose of the mobile phase tray. There's nothing really there. It's just an area for me to put these jugs, and that's what's in those jugs. Now, the problem is that these jugs and these mobile phases can be very expensive. The problem is that I told you this was high maintenance. The methanol comes in different forms or different blends. We could have lab grade, and we can have something called ACS grade. ACS stands for American Chemical Society. And there's a couple of other grades that are out there, just like gasoline grades, right? Your 87s and your 89s. And we also have something that's specially for HPLC. And we call this Hplc grade. And this is super clean. The HPLC, if its job is to separate contaminants, or if its job is to separate things from one another, any contaminant that's in our mobile phases will also be seen and be reported as being found in your sample when it's really not in your sample at all. It's coming from the mobile phase if it's not clean enough. So when we order mobile phases for the instrument, these mobile phases have to be HPLC grade. It's super clean, that has very low contamination in it. In doing so, super clean means extra steps to clean it. Extra steps to clean it means extra money that I'm going to have to invest in the mobile phases itself. So imagine yourself walking into the grocery store and buying two 2 liters of Coke. They're about $1.50 a piece if you catch them on sale. So you've paid $3 for 2 bottles of Coke. All right, total of 4 liters. That same amount of liquid for something like acetonitrile, 4 liters, again, the equivalent to 2 2-liter Cokes, can run about $800. And most of the time, when this liquid gets sent through the machine, the liquid goes into the waste disposal jug and it never really gets used again. So, it's very important for you to pick the right brand or grade of mobile phase, and it's very important for you not to waste the mobile phase, because these mobile phases can run into some money. The methanol HPLC grade, well, the methanol, that can be about $100 for 4 liters. Water is just our deionized water that we use. We make sure that it's as clean as possible, that there's no organic contamination in it at all. And the buffers, well, these are typically made from water and a compound. And these compounds have to be very good quality, like 99%, because most of these are solids, and that means 1% contamination, but it's okay because most of that contamination is non-organic as well. So the machine really only sees these kind of organic contaminants that are coming through. That's all that it does. Okay, so money can be invested into the mobile phases of the machine. And that's why the mobile phases, I take some time just to kind of explain that fact that these are not just cheap liquids that get poured into the machine. These are very expensive liquids, and you want to make sure that you use them with care, and you want to make sure that you use them properly. Do not waste. So for that reason, what you will find out is that we will not have the instrument on until you actually come to us to run samples. Then we will turn it on, because then it will start to pump liquids through the machine. And we don't want liquids to be pumping through if you're not there to inject anything. So we want to make sure that you're going to be meeting with us before we go through any of that process. If we know that you're coming and it's a for sure thing, and you call us up and you say, we're on our way, we'll be there in a couple of minutes, then we'll go ahead and turn the machine on. But until that point, it will stay off. And the reason is because it's wasting mobile phases. And that is how much these mobile phases are going to cost. Okay, so that's the story with the mobile phase. Something else that we need to talk about as far as mobile phases go is that you want to make sure that when the machine is on and when it's running, that these mobile phase jugs do not go dry. What happens is that the instrument is sucking liquid up out of these jugs, and it's using that liquid to separate your samples. The problem is that if these jugs go dry and there's no more liquid to suck out, the machine is sucking air into the system. And air is bad. We've already really talked about that before. So I do not want to see air in the system at all, right? Bad news. Because what's going to happen is that I'm going to have to get the air and the air bubbles out of the machine. And what I have to do on my end is shut the machine down, take out some of the tubing, make sure everything gets flushed, prime the machine, which could take hours on end, and then turn the machine back on and cross my fingers that it works fine. Do not let the jugs go dry. So every time you use an HPLC instrument, you want to take a look at these mobile phases, and you want to make sure that those jugs are filled, or halfway filled at least, and have suitable enough volume for you to do your job. Never let the machine go dry. On top of that, I'm saying this now because you're going to see in the software platform, it's going to be very important. Each one of these jugs will be labeled with an A, B, C, and D. So this tubing that goes into the top of the cap, and you can kind of see the tubing coming into the jug right here all the way to the bottom. Okay, well this jug is labeled Hplc Grade methanol for HPLC analysis. Okay, that piece of tubing has a stamp on it, and it will be stamped A, B, C, or D, because the machine and you have to be on the same playing field. So if I want the machine to pull methanol out, I have to tell the machine what line to pull from. So I will go in, and if this is stamped as A, into the software package, I will go into A because I know A represents the methanol jug because that's where I have the A line, and I will tell it to pull methanol, and to pull methanol I have to say pull the A, so it knows which one to start sucking from. So this is my way of going into the software to tell the machine which jug to pull. I can tell it to pull one, I can tell it to pull two at a time, I can tell it to pull four at a time. It's just really up to me on what I want to do. So We'll see that in the software when we get to that point, but each one of those lines are labeled as A, B, C, and D, so pay attention to which one's which. When you come into the lab and run samples on this machine for the first time, take a look at it. Remind us. Let's take a look and make sure that we can identify which mobile phase is which, and that way we can show you where these lines are stamped up at the very top. Okay, so that's the story with the mobile phase holder. It's not even a piece of equipment, it's just a tray, but we managed to spend about 15 or 16 minutes talking about the mobile phase holder and what it's doing and the importance of the mobile phase. So in the next video, we'll move on to the next piece, and the next piece is called our degasser.